So I did not quite get finished with the test, so I'll have the scores posted maybe an hour after we get out of here. So I almost got finished, but after I get finished with them, I still need to record the grades and things like that. So I don't think so. Let's see. No, I don't think so. We'll double check when the next thing is. Probably Tuesday night's probably the next one because we get kind of a break when we have test time. So, but we'll double check here though. Let's see. Well, let me just look on the website. How's everybody's week been? Been alright? Been going okay? Yeah, 2/22, so that's Tuesday, right? Tuesday's the next due date. But remember, any of it that you get done more than 24 hours ahead of time, you get 5% bonus on there. So. That's good, right? Okay. So, moving into chapter 2, kind of some of the stuff we did last time kind of fits in chapter 2 as well. So, our main goal in chapter 2 is to talk about functions and what those are. So, we're going to start off with the definition here. Bush. So we're defining a function here, and we're going to call our function f, lowercase f. So all a function is a rule, but it's a special rule. Okay, it works in a special way. So we're going to take what we're calling an element, so just a thing. Okay. Most of the time after today, when we're talking about functions, we'll be dealing with numbers, okay, but it's not strictly dealing with numbers when we're talking about functions. So we're going to call our thing that our function is taking x. And we're going to say x comes from a set, just a collection of things we're calling big A. We'll need that for some terminology we'll come up with here in just a second. So it's going to take that x, whatever that is, out of our set A and assign it to exactly one other element. And we'll call that one the x gets assigned to f of x. And then those f of x's will belong to some other collection of things. So we'll have some other set. Okay. Being very general with that definition. So what we're saying is we take an input of some sort and it gets assigned to exactly one output, is another way of saying that. That's what we're calling a function. So the exactly one part is important. That means two things going on with us saying exactly one. One part of that is that we're saying if we have an x, then it has to go to an f of x. And then we're also saying that if we have two different x's, they can't go to the same f of x. Because each x only goes to one f of x. So that's our idea of a function. So let's think about that relationship here a little bit. So here we'll have set A, and then we'll have set B. And let's see, we need some elements in set A, so we'll use numbers. They don't have to be numbers, but we'll use 1, 2, 3. And then let's do 7, 8, 9 over here. Okay, so if we have some kind of rule that gets us from set A to set B, from our inputs to our outputs, and it says that our rule has to assign exactly one element in set A to set B, so maybe 1 could go to 7, and so this will be our and then 2 could go to 8, and then 3 could go to 9. There's no reason why we would have to do it in that order. But if we had that relationship, okay, each member of our set A, the ones we're using for inputs, it goes to one member in set B, the ones we're using for our outputs. Okay? So we could call these over here, we could call these our x's. Right? And then these over here, we could call our f of x's. Or again, we could say these are the inputs for our rule, and then these would be our outputs. But that relationship there would give us a function. It will give us a function. It follows the definition. Okay, each x goes to exactly one f of x, so that's a function. Okay. All right, let's look at different situation. A different situation here. So same setup. 1, 2, 3. So we'll use exactly the same stuff. Okay. Let's think about a different relationship here. Okay. What if 1 goes to 7 and 2 goes to 7 and then 3 goes to 8? Would that one, my arrow's not real good there either. Would that one be a function? That one would not be. Okay. Or what? Hang on, wait. Would it be? I'm sorry, let me ask again. What do you think? That one would be. And that one would be. Still, the thing we have to think about, the thing we have to check on is our definition says each input, right, each x goes to exactly one output, okay, goes to exactly one f of x value. So here the thing that's maybe a little tricky is that 1 goes to 7 and 2 goes to 7. Okay, but that's okay because what are we thinking about? 1 goes to 7, so that's exactly one place. 2 goes to 7, that's exactly one place. 3 goes to 8, that's exactly one place. So we're okay there. We're okay. That one would still be a function. Okay. So here f is a function. Yeah, so yeah, two of the inputs can go to the same output. That's okay. That's okay. All right, so then let's look at our third situation. So, what about this one? What if 1 goes to 7 and 1 goes to 8, and then maybe 2 goes to 8 and 3 goes to 9? This one would not be a function. And the place where the rule gets broken, the definition gets broken, is here. Okay? Because 1 goes to 7, and it also goes to 8. So 1 is not going exactly one place. 1 is going to 2 values. Okay? So that's not allowed. Okay? So that's not allowed. So because of this part, okay, f is not a function in this case. One way you can remember that, it's one of my, probably my favorite way to remember it, is you can think about the inputs as being letters like you send in the mail, and then the outputs, you think about being like mailboxes. So it's okay for if you have a mailbox with more than one letter in it. Right? You can have more than one piece of mail in a mailbox. What can't happen is we can't have one letter go to two different mailboxes. That can't happen. You can't put one letter in two different mailboxes. So this one's not a function. The last one's okay. If we've got, so like letter 1 and letter 2 both go in mailbox 7, that's okay. If they just have more than one piece of mail, no big deal. It's one good way of kind of keep that in memory. All right, so that's a function. That's a function. Most of the ones we're going to deal with are dealing with numbers, right? So we're going to have some rule that takes one number and sends it to another number. Okay. One way we can express those rules is we could express in words. Okay. So we could have some rule that says like multiply by 3 and then add 2. Okay. So we'll take whatever input we get, we'll multiply it by 3, and then we'll add 2 to it. Okay. So that would be a function. It would be a function if you check it out. Typically, the way we would write that down, we don't normally write it in words. Okay. Normally, we write it in like a math equation form. Okay, so our notation we use, okay, so we'll say to get our f of x, our output, okay, we do whatever the rule says, and then we write the rule down as a math expression. So our input, if we're finding an f of x, our input's going to be x. So the thing that we would want to multiply by 3 on this one would be x, our input. So we would take and multiply 3 times our input, so 3x. And then after that, we would want to add 2 to it. And we would get our function, get our rule written down. So these two say the same thing. We just take our input, multiply it by 3, and add 2 to it. That tells us what our output value is. And then something else we can do with this thing, once we have our rule written down, we can take and try using some different inputs and see what we get for our output. So maybe if we want to use an input of 1, so the way we write that down is we say we're going to find f of 1. So if we use 1 as our input, what do we get as our output value? So you've done this before. You may have not just thought about it exactly like this. Another way of saying what we're doing is we're evaluating our function at 1. So we would take that 1 and multiply it by 3. And then we would add 2. So when we figure out what we get there, we get 3 plus 2. So our output value would be 5. Okay. So our input is 1. Our output, 5. And what we're doing by saying that this is a function, if we go back to our definition, we're saying that when we use 1 as our input, there's only one possible output that we can get. Right? So when we say plug in, when we're being informal, right? We say if we plug in 1, the only number that we can get using this rule is 5. Okay? If it was possible for us to plug in 1 and get more than one answer, then it would not be a function. It would not be a function. Okay. Questions so far? I know we're looking at some real basic things here, but we're trying to think about it in a specific way. We're trying to think about it from the perspective of functions and not just crunching numbers. Okay. So another way of saying the same thing, okay, is we could take and write our input as like the x coordinate of an ordered pair. And then we can write our output, which was 5, as the y coordinate of an ordered pair. Okay. So we could say, we're writing this thing down, so we're saying when we use f, an input of 1 gives us an output of 5. Okay. So another way of saying that is that the point, I got too close to that, the point 1 comma 5 is on the graph. We'll talk about those a little more later. But we can say that means that that's on the graph of our function f. Okay. So we wanted another point that's on the graph of our function f. How could we figure out another point that's on there? How do we find that one? We just picked an input value, and then we used our rule to figure out what our output value would be. So what's another input value we could use? Pick any number you want. 3. Okay. So then our rule says we take our input, multiply it by 3, and then add 2. So therefore our output value will get 11. Okay. So then the point 3 comma 11 is also on the graph. And really all the graph of a function, all that is we take all the possible inputs, see where they go as outputs, and then we plot all those points, and we get the picture, and we get the graph of our function. Okay. We don't always call functions f. We can give them other names too. G is another. Common name we could use. So f's nice because function starts with f. So use that one. But if we have more than one, we want to start giving them different names. So f, g, and h are common. Let's see what else comes up in WebSign. All f in that one. You can name them anything. F, G, and H are all pretty common. Okay, so on this one, let's go the other way. We said we could take it from words and then write down the math expression. So let's take the math expression and write it down in words. Okay. So let's see, how do we want to write this down? We could say take the input. So we're starting with our input number, whatever it is. And what's the first thing that we would do to our input value on this one? We would take the input, and then that's x, right? And then what do we do with it first? Subtract 1. Subtract 1. Then, once we subtract 1 and get that answer, what's the next thing we do? Take the square root. Okay. I'm just writing down what we're doing. Okay. You do have to be a little careful thinking about it. You want to make sure you're going in the proper order. We have an order of operations that we typically stick to. Okay. So there we would subtract the 1 first, and then after that we would take the square root. Okay. So let's take that function. I want to write it down again. And then let's find some values. So maybe we can try -1, 0, 2. So let's see what happens when we try these. So if we try -1 for x, try to see what we'll get for our output. And we'll have -1 minus 1. So that'll be square root of -2. Kind of have a problem there. So we need to put this in context. When we're talking about functions, we're only going to be concerned with real numbers, and we're not going to worry about i's and complex numbers. Okay? You can have functions that work with complex numbers, but that's way beyond where we're going to be. Okay? So if we're not allowing complex values, what would we get for our output on that one? But if we try to take the square root of a negative number, we could get a complex answer. But if we're not allowing a complex answer, then what's the deal? We can't get an output. We can't get a real number to come out of that. Okay? So we would end up not being able to find an output on that one. Okay. Same thing happens if we try 0. Then we'll get the square root of -1. We know we could call that I, but since we're only dealing with real numbers here, we would say no output. So it's possible that you could try to plug in some input value and it not work. Okay. That's okay. We're going to have some terminology for those values in just a second. If we go down to 1, the square root of 0 was square root of 0. 0, so that one's okay. If we use an input of 1, we get an output of 0. And if we use an input of 2, we end up with square root of 1, that's 1. But that's okay. That's okay. So let's talk about these situations. Okay, let's talk about these. Set of all inputs so here we're just concerned with all the inputs that we can use that will work and give us an output. So like for our function g here, -1, 0, those are not included, but 1 and 2, those would be in there because when we try to use those inputs, we do get an output. So the set of all inputs that give us an output called the domain of a function. Okay. So when we have input values that don't work, where we can't get an output out of our function, like an input of -1 and 0, we could say -1 is not in the domain of our function, or 0 is not in the domain of our function. All that means is that if we try to use those values as inputs, we don't get out a valid output. So those x values would not be in the domain of our function. Okay. And then one that's a little trickier to think about, another set that we're concerned with. Okay. Over here on the other side, the outputs that we can get, we want to think about all the possible values we could get out of our function. Okay. So we've got a name for that one too. Okay. A set of all possible outputs of a function. Anybody remember what that one's called? Got the domain, and then what's a range? Yeah, it's called the range. Okay. So thinking about this more along the lines of how we're going to use them in 112. Okay. The domain, and you see if we're thinking about using numbers as our inputs, real numbers as our inputs, and real numbers as our outputs, then the set of all numbers, okay, that give us an output of a function, that's our domain, and then the set of all the possible numbers that we can get out of our function, that's our range. Okay, that's our range. So we could go back and we could say, like, looking at our little examples here, Let's look at this one. So what would be our domain for that function? What numbers give us an output? All of them. 1 gives us an output, 2 gives us an output, 3 gives us an output. So 1, 2, and 3 all work. So 1, 2, and 3 would be our domain for this one. But what would our range be? Just 7 and 8, not 9. Okay, just 7 and 8, because the range is only the values that we can get as an output of our function. So here we've used all of our possible inputs, and we can only get either 7 or 8, okay, not 9. Okay. So domain and range. Okay. Domain is where we start, range is where we end up after we use our function. Okay. Let's just look at a couple more functions we could have. So maybe we could say f of x is x squared minus 7, or we could say g of x, maybe that one's just x plus 3. Turns out just about any kind of just a little simple expression you can think about writing down gives you a function. Okay, because there's only one way that you can do the arithmetic there. So whatever input you pick, you're only going to get one output. So that would be a function. Even things like we saw just a second ago, even if we have something like square root, there are some inputs that won't give us an output. Right? Like if we try -1 there, that's not going to work because we don't get a real number out. But that just means -1's not in the domain. That doesn't mean it's not a function. Okay. Something that would not be a function, we're not really going to see these, but if we had something like x plus or minus 2. Okay. That one would not be a function. Why is that not going to be a function? So let's give it a name, I guess. I'm going to call it n of x because it's not a function. And so like if we try to do n of 1, we'll get 1 plus or minus 2. So if we use the plus sign, we'll get 3. If we use the minus sign, we'll get -1. But that breaks the rules, right? That breaks the rules because a function, for any given input, we have to have exactly one output. We can't have more than one. More than one. That one's not a function. Okay? And then the last little thing in this section we need to look at is something called piecewise defined functions. And the thing about piecewise defined functions, why they get their name piecewise defined, we'll switch what rule we use for our function depending on what input value we're using. Okay, so like if our input's in a certain range of values, we'll use one rule. If our input's in another range of values, we'll use a different rule. And that's okay, that's allowed. So let's look at one. They look scary, but they're not bad after you understand how to use them. So here's one. So what this thing's telling us, we've got two different rules, and we just have to know when to use which one. So what this thing's telling us is that we take our input value, and then we check it with the conditions that come at the end. So this first one's saying that we're going to use the top rule if our input value is smaller than 0. And so if our input value is negative, then we'll use the top rule. Okay? Or if the input value we pick is 0 or bigger, greater than or equal to 0, then we'll use the bottom rule. Okay? You don't ever use both. Okay? You're just going to use one rule at a time. And the way you decide is you just check your input and see which one it matches up with. So let's find f of 1. Okay. So if we want f of 1, so we're going to use 1 as our input. Then should we use the top rule or the bottom rule? The way we think about it is we take 1, our input, and compare it to our conditions down there. So is 1 bigger than 0 or smaller than 0? 1's bigger than 0. So since 1's bigger than 0, that means we're going to use the bottom rule. We're going to use the bottom rule. So we would take 1 and we would square it and get 1. That's using this rule. Okay. You don't use both, because if you try to use both, you're going to get more than one answer, and then it's not a function. Okay. Just use the proper one. Okay. What about we had f of negative 1? We want to find our output when our input's negative 1. Negative 1 is smaller than 0. Okay. So that means we would use the top rule. Okay. And get 0. So we use the top rule because negative 1 is smaller than 0. Okay. And then the trickier case would be like, what if we want to find f of 0? Which rule do we use, top or bottom? When use the bottom, because the bottom says use that when f x is bigger than or equal to 0. So we would use the bottom. So we would have 0 squared and get 0. So that one goes to the bottom again. Okay. Okay. Questions so far? Okay, you can't have more than one piece. Okay, so we could have something like this. So we'll give it a different name. We'll call it g of x. And there's no limit on how many different pieces you can have. And do one with 3 pieces here. So let's see, we'll do this one. Now, hang on. There we go. Okay. There's one with 3 pieces, and I got kind of crooked there, sorry. Really helps being neat. Trying to write this down. Okay, so this one says we use the top rule if our x value is less than negative 2. We use the middle rule if our x value is between negative 2 and 4. And then we use the bottom rule if our x value is bigger than 4. Okay. One thing to watch out for is where these equal bars are. And so the case where x is -2 and the case where x is 4, we would use the middle rule. We could take the equal bar off that one and put it on this one. Or we could take it off there and put it on this one. So then let's find a couple values real quick. So like not f, it's g. G of -3. Which one would we use for that one? Yeah, we use x, we use the top. So then we just plug in -3 and we're done. And that rule's pretty easy. Our input is the same as our output. Well, if we wanted g of -1, which rule is that going to be? It's going to be the middle one, right? Because -1 is between -2 and 4. So we would use the middle rule. So that means we'll take -1 and square it and then add 1. And there we'll get 2. Okay. We want a g of 5. That one would be our bottom rule. So we would take square root of 5, and there's nothing we can do to simplify that, so get square root of 5. You could get a decimal approximation, but square root of 5 is fine. And then what about, we want a g of -2. Which one we use for that one? The middle, because we've got the equal to bar on there. So for that one, we would use the middle. So we would take -2 and square that, plus 1. 4 plus 1, we would get 5. Okay. So they're not any harder than the regular functions. They're just, we have that one more step where we have to check which rule to use, but that's all. As long as you know how they work, they're not hard. They look pretty scary until you know what's going on, because you got all that stuff up there. But right. All right, so one more big idea. So let's take a function. There's a function. What if? So we know if we want to use a number as the input, then we just put it in there where x is, and then do our arithmetic, figure out what we give our output. But we don't necessarily have to use numbers. We could use other variables, or we could use some other letter. So like, what if we wanted to find f of a? What do we do? We can still use it. We just take and put it in place of x in the rule. So f of a, instead of x squared, we would have a squared plus 1. And I don't know what a is, so we don't have any arithmetic to do there to simplify. That's okay to do that. Other kind of weird things we could do. What if we wanted to do like, we wanted to find f of x plus 1? We can do it. We do it the same way. Maybe it's a good idea to just put some parentheses where our x was, and then we just plug in whatever we want to use for our input. In this case, our input's going to be x plus 1. So that would be what we get, x plus 1 squared, and then plus 1. If we wanted to, we could multiply that out. So that would be like x squared plus 2x plus 1, and then plus 1. So we would get x squared plus 2x plus 2. So either one of these, this is valid, and then this is also valid. That's the simplified version. Sometimes we'll leave it, sometimes we'll want to multiply it out. It just depends on the circumstance. Okay. Alright, and then one other kind of weird thing that kind of comes out of nowhere right here. And let's look at another problem. So here's a function. Okay. Got a couple of things we want to find here. And what we're going to end up finding, okay, we're going to do it step by step, but what we're going to end up finding is this thing called the difference quotient. It's something you're using in calculus. This is technically pre-calculus algebra, even though a lot of you probably don't have to go on and take calculus. It works out here at JSU. So if you don't have to go on and take calculus, sorry, you have to deal with it too. That's just kind of unfortunate. So here, let's find a couple of things here. So first of all, let's find f of a. So we just plug in a instead of x, so we'll get 2a plus 1. Okay. Second thing we want to find is weird, because we don't have any context for why we would want to find something like that. We want to find f of a plus h. So all that means is we can put parentheses where the x was, and then instead of x we put in a plus h. And on this one we are going to want to simplify. So that means we'll distribute this 2 and then combine any like terms we have. So we'll get 2a plus 2h plus 1. Nothing else we can do with that. And then the last thing we want to find is the difference quotient. It looks really weird when we don't have any context for it, but you've got a problem like this in WebAssign, why I'm walking you through. Okay. So the third thing we want to find is we want to find f of a plus h minus f of a all over h. So this part is this. Okay. This part is this. So we've already found the two pieces. We just need to plug them in. Okay. So we'll have 2a plus 2h plus 1 minus. You do have to be careful here, because if you have more than one term, you got to distribute the minus sign. So the thing we want to subtract is 2a plus 1 over h. And then the big thing we want to do on this problem is we want to simplify all that mess. Okay. It's actually kind of nice to work with, because we get quite a bit of stuff that cancels out. And so if we distribute the minus sign, we'll get 2a plus 2h plus 1 minus 2a minus 1 over h. And when we go to simplify that, combine like terms, what happens? What do you see? 2a minus 2a, those cancel out. And plus 1 minus 1, that cancels out. So we end up with 2h over h. What happens with that? Anything over itself is 1, right? So h on top, h on the bottom, that cancels out. So we just end up getting 2. So even though that thing was really messy, we end up getting a nice answer out of it. So one of the problems in WebAssign, I'll walk you through that too. It'll give you a function. It'll say find f of a, so you just plug in a where the x was. It'll say find f of a plus h. So put parentheses wherever your x's were in the function, fill in a plus h, and then simplify it out as much as you can. And then when you go to this third step where it asks you to find the difference quotient, you just plug in your answers from the other two parts in the right place with the minus sign in between them, and then simplify. You do have to be careful though where the minus sign is, because everything that comes after the minus sign, you got to distribute the minus sign to those. Okay? That way everything cancels out the way it's supposed to, and you get the 2 down there. All right. Questions? No, not very lively. It's been a long week. Been a long week. All right. Well, it's supposed to be stormy, so we'll go short today. Okay? Go short today. All right. That's it. Okay, we'll stop there. So you go get somewhere where you don't get stuck in the rain. So here in about an hour or so, I'll have